Let us come back and learn the next concentration unit, that is your molarity and molality. We have already done mole fraction. We have also learned what is volume percent as well as mass percentage. So when I speak about molarity, basically first let us learn the formula and then start applying it in the numericals. So when I have to speak of molarity, one more concentration unit, it is denoted by capital M. When I have to learn about molality, it is denoted by small m. Done? Yes. So capital M is equal to number of moles of solute divided by volume of solution in liters. Okay, simple. Now let us come back to write this. Molality is equal to same, numerator is the same for both. Number of moles of solute divided by, here you are going to use or this one speak about weight of solvent in kg. Done. Now what is number of moles? Basically number of moles is nothing but weight by molecular weight. So let us write that weight by, okay, weight of solute divided by molecular weight of solute into 1 by V. Done. Same story here. Whenever you have to write number of moles, the same thing, weight of solute divided by the molecular weight of that particular solute given into 1 by W. Yes. Now further, if I have to, now this is your whole concept. Let's start writing. Suppose if I am like making it to the total of 1000, that is 1 liter. So how do you write? Weight by weight of solute by molecular weight of solute into 1000 by V in liters. Done. It's the same thing if I have to write here. Weight of solute by molecular weight of solute into 1000 grams by weight in grams. Simple. Okay, weight in kg. Okay, 1000 by weight in kg. I'm sorry, weight in kg. Solvent, weight of solvent in kg. Now come back and write the units. When I have to write the units of this, observe carefully. Simple. What is this? Number of moles. So mole divided by volume. So it is in liters. When it comes to the numerator, this becomes liter inverse. This is the unit for molarity. Right. Let us come back and write the units for molality. Now what is molality? Number of moles. So same, moles divided by weight of the solvent in kg. Kg inverse. That's it. So if you learn the basic formula, it's easy for me to apply in the numerical. And the weight. That's the reason I've taken this numericals. Let's see. So first of all, what is given to us? I have to find out molarity here. I have to find out molality here. Simple. Now let us write what is given to us. So given data is weight of ethanol is given. Okay. How much is it given? 50 grams. Done? Yes. Here what is given? Weight of methanol is given. So given data, weight of methanol 64 grams. Done. What else is given? Molar mass is given of ethanol is given 46 gram per mole. Here molecular weight of methanol is given 32 gram per mole. Done? Yes. What else is given? Volume is given here because it is molarity. Volume of the solution is 500 ml. Here weight is given. Weight of solvent given is 200 grams. No, simple. I'll just make it easy for you all. Now, important thing, I have to calculate molarity. So, molarity is number of moles by volume of the solution in liters, and here number of moles by weight of the solvent in kg. Let's come back and solve. First, whenever such numerical is given to you, try to first standardize it to 1000 ml. That's important. First, what should you do? Simple data. Don't directly substitute in the formula. What can you do? Weight of ethanol, or number of moles. I can, okay, later we'll calculate number of moles. First let us calculate weight of ethanol per liter, right? So what is given to us? 50 is given to us, volume is 500 ml, standardize it to 1000 ml. Then you cancel it, 1000 done. 100. So what did we get? 100 grams. No, this is grams. Done. So this is your weight in per, means you have standardized it to 1000 ml. Now here also the same thing. Weight of methanol per 1000 grams, because it is molality. So what is the weight of methanol given? 64 divided by your solvent is 200. Standardize it to 1000. 1 2 2 here, 2 3 2s are 6 and 2, so you have got 320. Now what is this weight? This is grams, isn't it? Over. I've got both. Now what should I do? I have to calculate number of moles. So what is number of moles? Basically it is weight in your gram per liter, which I've got, divided by molecular weight, that is gram per mole, isn't it? Yeah. Here also the same story, number of moles I have to calculate. But here what is the difference? Here we have taken weight in gram per liter. Here I have taken weight in grams, divided by, here molecular weight, it's the same here also, molecular weight in gram per mole. Let us solve. What did we get weight as? 1000 grams divided by molecular weight given is 46 gram per mole. So when I solve this, I get 2.18. So it is number of moles. Molarity formula is mole liter inverse, because already liter I have taken, mole. Done. Then next come back. I have to substitute here. 320 is the answer in grams, divided by molecular weight 32. It goes 10 times 10. So number of moles, molality unit, when I see it is, that is mole per liter inverse. This is mole per gram inverse. Right. So students, we've already seen the concept of molarity, isn't it? Yes, we've learned the formula and how to go about with that. We've already seen. So let us start solving important numericals of molarity. Basically, your molarity concept, finding the concentration, the n number of numericals which are related to this concept, and we'll be doing one after the other, both your NCERT questions as well as your comprehensive questions. Fine. So let us read the first question. So when I have to go with the first question, let us see. What did they give us? Calculate the mass of sodium acetate, that is the formula given to us here, required to 500 ml. Okay, required to 500 ml. Like, there's a small word missing, isn't it? So let us read again. Calculate the mass of sodium acetate required to make this. There should be a word here, make. Okay, make 500 ml of 0.375 molar aqueous solution. Molar mass of acetic acid, sodium acetate is 83.02 gram per mole. So basically, what did they ask me? They asked me to calculate the mass. Fine. So for such things, first of all, when they have given you such data, try to first note what is given to you. So what should you find out? I need to find mass, right? So what else is given to you? They've given you the molar mass of solute, isn't it? See here, this one. They've given you molar mass of solute. Molar mass of solute. How much is given to you? Solute is nothing but sodium acetate. It is given 82.0245 gram per mole. Okay, right, gram mole inverse or gram per mole. Done. What else is given? Volume is given to you. Volume, how much is given? Volume of what? Volume of solution is given to you. Volume of solution is equal to 500 ml is given to you. Done. Fine. So I should find mass of solute, isn't it? This is nothing but mass of solute. So let us come back and write the formula. Fine. So anything else is given? They've also given molarity. See here, 0. Calculate the mass of this one. So of 0.375 molar aqueous solution. Molar aqueous solution is nothing but molarity. Molar aqueous solution means molarity, that is 0.375 molar, capital M. Right. So let us write the formula first. According to the formula, molarity is equal to W into our mass of the solute, isn't it? That's mass of the solute by the volume of the solution in liters, isn't it? So what is that? Mass of the solute can be written as weight by molecular weight, right? Then small m, let us write this into volume of the solution. So volume of solution. Fine. So this solution is in ml, and now weight by molecular weight into 1000. Right. So fine. So now substitute the values. Now what do we need? We require this mass, isn't it? So what do we require? We require the weight. This weight. Molar mass is already given. So I require this weight. W I require. So when I take this mass of the solute, fine. So when I take this W out, I'm getting this W out. I'm cross multiplying molarity with this. Okay. This W out and this molarity out. Fine. W is equal to molarity is how much? Molarity is nothing but 0.375. This is the mass which they have asked, and after that into how much is the molar mass given to us? It is nothing but 82.0245 into what is the volume of the solution given? 500 ml. 500 ml divided by 1000, isn't it? This goes down 1000. So how much do I get? I'm going to get an answer of 15.379 grams. That is nothing but, if I approximate this, because the significant number is more than 5, this becomes 15.38 grams. That's it. This is your first numerical. Hope this is clear to you all. Fine. So let us see the next question in molarity. So here in the next question, what do they give us? Right, let's read. Calculate the concentration of nitric acid in moles per liter. Okay, in moles per liter. Fine. This is the same sentence which is repeated, in moles per liter, in which one? In a sample which has density of 1.41 gram per milliliter, and the mass percentage of nitric acid in it being 69%. Fine. So let me first write what is given to us. So in the given data, yes, what's given? Density is given 1.41 gram per liter. Right, then what did they give us? What should I calculate? I need to calculate the concentration of nitric acid in moles per liter. So concentration of nitric acid in moles per liter means, what does that mean? Right, basically they are asking us to find the concentration of nitric acid, like means they've given the units, right? They're asking us to find the molarity only, nothing else. Fine. Moles per liter unit is nothing but for molarity, isn't it? Fine. So that is what they're asking us. Fine. That's okay. Now I need to find capital M. Then after that, is there anything else given? They've given us mass percentage also. See here, mass percent of nitric acid is being given 69%. So mass percentage, what does it mean? That means 69% HNO3, right, means 100 grams of solution. What does this mean? 100 grams of this one contains what does it contain? It contains 69 grams of HNO3. This is what it means. Fine. So what is mass of HNO3 now? Yes, so mass is equal to 69 grams. Okay, fine. So let us find the molar mass. I need to find molar mass because of molarity formula. I need molar mass also. So molar mass for HNO3. Molar mass of HNO3. How do I calculate this? I calculate molar mass. First mass of hydrogen is 1.0079 plus. What is the mass of nitrogen? 14 plus 3 into 16 into 16. How much do I get? I come to 63.01 gram per mole. Okay, I got molar mass. So everything. Now let's come back. What is the formula for molarity? Molarity is equal to moles of the solute. That's the mass of the solute, isn't it? Right. That mass is equal to weight by molecular weight into 1000 by volume of the solution, right? Isn't it? Yes. So did they give us anything? They've given volume. They've not given us volume. They've given us density. So calculate density is equal to mass by volume. Let us write this as step 1. Let us write this as step 2. Density is equal to mass by volume. So cross multiply this volume. Volume is equal to mass by density. How much do we get? What is the mass given? 100 grams, isn't it? 100 grams divided by how much is the density given? 1.41. So how much will this come up to? Okay, we can directly leave that and calculate. Fine. So now substitute volume. Now substitute what is the weight of this one which they've given? Nitric acid, because this is for the solute, isn't it? This is for the solute. This is for the solution, isn't it? Fine. So weight of solute, how much did I write? 69 into 1000 divided by what is the mass? This one, okay, 63 grams, which we have got 63.01 into what is a volume? It is, volume is 100 grams. 100% means 100 grams, isn't it? 100. Okay, so here we have already got this volume 100 into, this is already there, into 1.41, because volume is 100 by 41. When it goes, it becomes the reverse. When I solve this, I get an answer of 15.43 molar. This is what is the answer, right? Hope this is clear to you all. This is how you're going to do. First, see what data is given to you all and see what to calculate, and after that write the formula and substitute in the formula. Right. Now let's come back and do the next sum, which is related to your molarity. So we have seen 2 combinations. Now let's see the next one. So in this question, what did they give us? Here again, they've asked us, this is, as I said, all these are molarity numericals. Let us read the question first. What is the concentration of sugar, that is your C12H22O11, in mole per liter? Fine. If it's 20 grams are dissolved in enough water to make a final volume of up to 2 liters. Right. So first of all, they are asking us to find concentration of sugar. So the concentration, what we are speaking concentration in terms of molarity here, isn't it? Yes. So I need to find the concentration, of this particular thing. Simple. It's a direct question rather, if I have to say. First of all, so when I have to find the molarity concept, first of all, let us write the formula. So molarity is equal to weight by your molecular weight into volume in liters. This is what is your formula, isn't it? Now let us write the data which is given. So let us write given data and substitute in the formula. When I have to see, first of all, what do we require? Do we have weight here? Yes, W is given to us 20 grams. W is equal to 20 grams is given to us. Did they give us your mass or volume? Okay, volume, we'll see. Volume is given to us enough water to make up the final volume to 2 liters. Okay, they've given us volume as 2 liters. Already this is in liters, this is also in liters, not a problem. And after that, did they give us molecular mass? Okay, molecular mass. This mass is not given to us. That mass I'm going to calculate for C12H22O11. How much is this? C12H22, it's nothing but 12 into the mass of carbon, right? Fine, 12.01 rather, plus 22 into 1.007 of hydrogen, plus 11 into 16 of oxygen. Total this comes to 342 gram per mole. Okay, all are ready. I can directly substitute in this, isn't it? Yes, let's substitute. How much is the weight? 20. How much is the mass given to us? Your calculated mass. It is 342 into 2, because everything is in liter. So when I calculate this, when I solve this, I get an answer of 0.02092. Fine. So here, what are the units? The mass is in gram per mole, isn't it? Yes, weight and this and gram per mole and gram per mole. This is also in grams. This is gram per mole. Fine. So this grams and this grams gets cancelled. So what are we left with? Only mole per liter. So what are the units here? Mole per liter. This gram and this gram gets cancelled. This is already mole. This is already liter. When this goes above, this becomes mole per liter. Fine. So this is your answer. So finally, how can you write this? 0.0292 molar solution. This is what is. This is how you're going to explain. Hope this is clear to you all. Yes. Let us come back and see the next question. Fine. So here in the next question, this again, as I said, we'll be doing one more molarity numerical. All these are molarity numericals, different variations of molarity numericals. Right, now let's start solving this numerical. First of all, let's calculate the mass percentage. Fine. So percent by mass and mass percentage, both are the same. So when I have to do the first part, let us just solve the first part and see. Explain this mass percentage. What actually is mass percentage or percent by mass? Mass of the solute by mass of the solution into 100. That is what is mass percent. But here, what did they give us? They've given us 15 ppm. They've given this. This is what is given. Contamination by 15 ppm by mass. That is why I'm picking up this concept. So 15 ppm is nothing but 15 parts in 1 million. That is 10 raised to 6 parts. This is what is 15 ppm means. Right? So let us write. Now percent by mass. When I have to calculate, yes. So mass of the solution they've given here in terms of 15 ppm means I've already written this, pick that thing here, 15 into 100 is already there because it is a percentage divided by 10 raised to 6. So how much do I get when I solve? I get here an answer of 1.5 into 10 raised to -3 percentage. This is your ppm. Fine. Let's come back and do the next one. Determine the molarity of chloroform in water sample. So when I have to determine the molarity, yes. So let us do the second part. So molarity, what is the formula? Weight by molecular weight into 1000 by your by volume into volume of sample. Okay, volume of sample. So what data is given to us here when I have to see? Fine. So let us see whether weight is given to us, right? So they've given here basically the sample of drinking water here in this particular equation. They have written like they've given sample of drinking water was found to be contaminated, carcinogenic. Only mass is given, nothing else is given to us. Fine. Okay. So now I can easily start with this numerical. Why? What am I trying to tell you? It's a contamination in water. That means, fine. So here your already mass we have got, isn't it? What is the mass? That is your mass percentage. This molarity, that mass I can directly substitute into 10 raised to -3. This 1000 is also there divided by, yes. This is what is the molar mass of this? Molar mass of which one? This is chloroform contamination. This set. Fine. So chloroform contamination means I can easily find, isn't it? So CHCl3. How much is this? Carbon comes to 12 plus hydrogen is 10079. How much is chlorine? 3 into 35.5. Okay. When I solve this chloroform, I get an answer of 119 gram per mole. Okay, this is what is your weight. So substitute that value 119 gram per mole, that is your 119 into volume of the sample is 100 ml, because they've given parts per million, that the thing they've given, isn't it? So into 100, done. Fine. So why did I take this? Because 1.5 into 10 raised to the -3. 1.5 10 raised to the -3 means 1.5 10 raised to the -3 grams are present in 100 grams of sample. That is what is that? Parts per million is that only. Right. So that is why I've taken 100 here. Right. When I solve this molarity, I get an answer of 0.000126. Further, when if I have to write, molarity is equal to 1.26 into 10 raised to the -4. Hope this is clear to you all. They've given parts per million. First, you need to convert the parts per million. This is nothing but, as I said, it is 1.5 into 10 raised to the -3 percentage. It's nothing but, when you write in grams, 1.5 into 10 raised to the -3 grams present in 100 grams. This is present in 100 grams. That the same concept I've applied there also. Fine. So let us do the next numerical, which is based on molarity. Fine. So here there's one reaction given to you all. Basically, these are all comprehensive numericals. Let's do reaction 2Br minus aqueous plus Cl2. Aqueous gives 2Cl minus plus Br2. Okay, is used for commercial preparation of bromine from its salts. Okay, if we have 50 ml of 0.060 molar solution of NaBr, What volume of 0.050 molar solution of chlorine is needed to react completely with Br minus ions? Okay, fine. So basically, they've given us a lot of information here. They've given us your M1, they've given us like your V1, they've given us M2. I need to find V2. Okay, let us write what actually are this. Fine. So first of all, when such question is given to you, write the formula which you're going to use. How did I know that it is M1, V1? Basically, they've given different molarities, isn't it? Here molarities are given, volume is given. They're asking us to find the other volume. So that is the reason I could predict that formula. Fine. So first of all, let us take the formula M1 V1 is equal to M2 V2. Right, but here they've given one question here, reaction here, isn't it? Suppose if I assume, let us take this M1 V1 in terms of your Br, because it is the stoichiometric equation is 2, isn't it? So I'm taking this as 12. Let us take your M2 V2 in terms of chlorine. Okay, right. So here chlorine, how much is chlorine? It is only 1, isn't it? So 1. So take this relation in this way and see. Fine. Now let us write what information is given. Here they've given us M1 is equal to 0.060. This one, this M1. Fine. How much? What is V1? V1, I need, okay, by V1 how much did they give you? 50 ml of 0.061. So V1 is 50 ml. How much is M2 given? M2 given is 0.050 mole liter inverse. Okay, so M1 also mole, the same thing, 0.06 mole. Molarity is nothing but mole per liter inverse only, you know. Yes. So V2 is how much? I need to find. So let us come back and substitute in this formula. So take these values. V2 is equal to, now cross multiply this. What do you get when you cross multiply this whole thing? It becomes a reverse order, isn't it? So V2 becomes M1 V1 by 2 into 1 by M2. Correct? Yes. So substitute the values now. V2 is equal to M1 is how much? 0.060 into how much is V1? 50 divided by 2 into how much is M2 here is 0.050. So finally V2, how much do I get? When I solve, I get volume of 30 ml. This is your answer. This is how we are going to do the sum. So hope this concept is clear to you all. I'm gradually doing all the varieties of numericals which you should be practicing for molarity. More than this you will not be questioned. So try to practice all the types of molarity numericals at one stretch. Yes? Yeah. So let's come back and see the next variety question. Here they've given us molarity and normality. Both the concepts are linked here in this case. So let's read the question. How much volume of decamolar solution of sulfuric acid is required to prepare 500 ml of solution with density 1.03 gram per liter and having mass percentage equal to 40%? Fine. Also calculate the molarity and normality of the resultant solution. Fine. So here I need to find both molarity and normality. So first of all, you should know the formulas of these two. Then only you will be able to do the sum. Fine. So first of all, molarity, fine. Normality, molarity, both the formulas will write. But here you should one thing remember. They've given a density. I've taken one class where I said relation between molarity and density. There's one formula also directly given. I'll write that formula first so that I can easily apply. So for molarity, there's one formula as I said just now. Molarity in relation with density. What is that? Molarity is equal to percentage into 10 into D by molarity of the given sulfuric acid. Fine. So the second one, when I have to speak about normality formula is molarity into molecular mass divided by equivalent mass. This is one more formula. Now let's substitute here. In this case, what do they give me? What is the percentage of this one given mass equal to 40%? They given 40 into 10. How much is the density given? Direct substitution. 1.03, right? How much is the molar mass of sulfuric acid? This is for sulfuric acid, isn't it? We're speaking in terms of sulfuric acid. Sulfuric acid molar mass is 98, isn't it? So how did I calculate sulfuric acid? Like that. So 2 into 1 plus 32 is the molar mass of sulfur plus 4 into 16. I got 98 gram per mole. This is okay. Yes, now substitute the value here. You get 98 gram per mole. When you divide this whole thing, you get an answer of 4.20 mole per liter. Okay, this is over. Your molarity value you've got. Fine. So now one more thing. What did they say? Okay, volume of decamolar, they said. How much volume of decamolar solution, they said. Fine. So volume of decamolar, so decamolar is nothing but 10 moles, isn't it? 10 molar sulfuric acid B, right? So then what can I write? So that decamolar, if I take volume into 10, so how much is the volume given to us? They've given 4.2, isn't it? Yes. So I've got, means the volume which I've got, that particular thing, volume into 10. That means, what am I trying to explain? I'll show it in a substitute. What am I trying to explain is, let the volume of decamolar is nothing but 10 molar. Okay, deca means 10, isn't it? Decamolar sulfuric acid solution, okay, required B, that will be VML. Fine. That means V into 10 is equal to 4.2 into 500, isn't it? Okay. So why am I finding? I need to substitute this value in my normality also, isn't it? Right. So V is equal to 4.2 into 500 divided by 10. How much do I get? I get an answer of 210 ml. Okay. Now, second, because I need to find for this one, isn't it? Equivalent mass, nothing but your basicity by your this one, the base divided by the mass divided by the molar mass divided by the basicity, isn't it? Yes. So that's why I'm trying to find this value. So 210 ml I've got. Now, what is basicity? Basicity of sulfuric acid, H2SO4 is 2, isn't it? Yes, 2 ionizable ions. Fine. So now equivalent mass you calculate. Equivalent mass of sulfuric acid is equal to molar mass divided by basicity. It comes to 49. Now it's easy for me to substitute. Normality is equal to molarity into molar mass divided by equivalent mass. Now what is molarity? I got 4.2. What is the molar mass of sulfuric acid? 98. What is the equivalent weight? Which I got 49. So when I calculate, I get an answer of 8.4 normality. This is how you're going to do the sum. This is directly molarity in relation with density is one numerical. Next one is a normality. Fine. Hope this is clear. Let us come back and do one more sum. Keep noting it and you keep solving numericals. When you start solving more number of numericals, your concepts will be clear. Yes. So let's do this. Next question. Commercially available concentrated HCl contains 38% of HCl by mass. Okay. What is the molarity of this solution? Density again is given, same variety of question. What volume of concentrated HCl is required to make 1 liter of 0.1 molar HCl? Okay, fine. So in this question, what should you do? You need to find the molarity and you should also need to find the volume, isn't it? Yes. So let us do step by step. So first of all, molarity, as I said, when density is given, what formula can you apply for molarity? Molarity is equal to percentage into density into 10 divided by molar mass. This is one formula which you can apply. Fine. So let us see. Now in this case, percentage, how much they give me? They've given 38%. So right now 38. How much is the density given to us? It is 1.10 into 10 divided by, what is the molar mass? Molar mass of what? Of HCl, isn't it? HCl is nothing but 36.5. How did I get this? Hydrogen is 1 plus chlorine is 35.5. So this comes to 36.5. I have got this. So how much is the answer? When you divide this, you get molarity is equal to 11.45 mole per liter. This is over, isn't it? Okay, now done. Now I need to find the volume. First part is over, second part I'll do it. What volume of HCl, concentrated HCl is required? So when I've asked us to find the volume, right? So in the second concept, we have molarity equation, isn't it? So let us write according to molarity equation. What is molarity equation? Molarity equation is M1V1 is equal to M2V2. Now M1V1 will take it for concentrated HCl, M2V2 will take it for dilute HCl. Okay, yes. So what do we require? They've asked us to find what? They've asked us to find what volume of concentrated HCl I require. So they're asking us to find out what volume I need to find. So okay, sorry, I need to find this volume. So when I take out this and substitute the leftover values, I get an answer. This one as 0.1 into 1.0 by 11.45. So this comes back to 8.73 into 10 raised to minus 3 liter. If I have to convert in milliliter, 8.73 milliliter. That's it. This is your volume of concentrated HCl V1. This is how you're going to do this. Yes. Hope this is clear. Concept is clear. I'm trying to do all types of numericals. Please try to practice it. Fine. Let's come back to one more question. So in the next question, yes, a sample of sodium hydroxide weighing 38 grams is dissolved in water and the solution is made to 50 ml in a volumetric flask. Okay, what is the molarity of the resulting solution? Fine. How many moles of sodium hydroxide are contained in 27 ml? Okay, so in this particular question, fine. What did they give me? What should I find out? I need to find out first of all molarity also. Then I need to find out how many moles also. So both the concepts are given to you. Right, we'll do step by step. First of all, moles of sodium hydroxide. Let us do that and then come back. Moles of sodium hydroxide in 50 ml. Okay. Because I'm from the known, we are going to the unknown. In that way, we'll go. So let's see. I have to solve this. Moles of sodium hydroxide in 50 ml. What is this? What is mole? Mole is nothing but weight by molecular weight. Weight of sodium hydroxide by molecular weight of sodium hydroxide in grams. So weight of sodium hydroxide is how much? 38 grams. That's given, isn't it? See here. A sample of sodium hydroxide weighing 38 grams. So 38 grams divided by molecular weight of sodium hydroxide is 40 gram per mole. This is also over. These two are over. So this is your number of moles. So when I what did they ask us? Now moles of 1 liter of solution, because how many moles are contained in this, isn't it? Okay. Now when I have to take now moles of sodium hydroxide in 1 liter solution, the same thing. Let us find moles of, therefore moles of NaOH in 1 liter solution, right? Fine. So 27, there's some information also missing, isn't it? 27 ml of 0.15 molar solution. Okay, this is important. Okay, I've left this data. Okay, so now substitute. This is there in 50 ml. So the 1 liter, if I find 38 by 40 into 1000 by 50. This is for 1 liter, isn't it now? Yes. So how much does come to? 19 mole per liter. So now this is over. Fine. So now I need to find for this, the second, this one, they have given 0.5 molar. So we have got one answer for 1 liter. Okay, 1 liter, we have found this coefficient. Now we'll see for 27 ml. Right, let's see what am I trying to tell you. 1 liter of solution. Now they said, now I standardize this to 1 liter. The second concept is, they said, according to the second one, 1 liter of solution, which one of sodium hydroxide NaOH contains 0.15 moles. Okay, so 27 ml rather. 27 ml of solution contains how much, isn't it? How much? So cross multiply 0.15 into 27 by 1 liter means 1000 ml. This is equal to 4.05 into 10 raised to the minus 3 moles. Okay, this is how you're going to do. So start from your known factor, and then come back to the thing which you need to find out. Yes, so this is over. So let's come back and see the next question. Let's come back and see one more numerical. Here we are supposed to find the molar conductivity. Right, let's see, I've already written the formula. Let's read the question first. Resistance of 0.2 molar solution of an electrolyte is 50 ohms. Okay, right. The specific conductance of the solution of 0.5 molar solution of the same electrolyte is 1.4. Okay, as in meter inverse, and the resistance of the same solution of the same electrolyte is 280 ohms. The molar conductivity of 0.5 mole solution of electrolyte is this. Okay, I need to find the molar conductivity of that. Now, let us start with the first thing. First, let us take the first solution. This is the first solution. Let us solve this. How? So, let me take for first solution. For first solution, let us write the data which is given to us. What do they give us? They have given me 0.5 electrolyte is, but okay. So, K value they have given to me. Kappa given to me is 1.4 sm. Resistance capital R given to me is 50 ohms. 50 ohms. Right, and after that, more concentration is 0.2 molar. Okay, done. This is over. Now, what should I find out? I have to find out the molar conductivity. Basically, what is the molar conductivity formula? Let me write that first. Molar conductivity formula, which you have already learnt. Molar conductivity formula, which I have already taught you in the numericals and the formulas to be noted. That is lambda m is equal to kappa divided by 1000 into m. Isn't it? Now let me come back. So for the first solution, if I have to find, first I'll take specific conductance. According to the formula which I have to substitute, specific conductance kappa is equal to 1 by R into L by A. What is K value? 1.4 Sm plus 1 is equal to 1. What is this? 1 by R? That is 1 by 50 into L by A. Because I don't know L by A, isn't it? Cell constant. Take that L by A outside. So L by A is equal to, okay, capital A, sorry, area of cross section. L by A is equal to 50 into cross multiply this, 50 into 1.4 Sm inverse 1. Okay, first one I got. Now, for the second solution. Now let us try with the second solution. When I have to write the second solution, let me write that. For second solution, how much is given to us? For the second solution, this said the specific conductance of the solution 0.5 molar. Okay, right. The same electrolyte 1.4 and the resistance of the same solution, same electrolyte is 280 ohms. Okay, and let me write the data again. R given to me is 280. L by A given to me is already I found in the earlier value, that is 50 into 1.4 inverse 1. Done. So conductivity is equal to 180 to 1.4 into 50. When I solve this, I get 1 by 4. Now it's easy, isn't it? Now K is ready. I can substitute in this. Molar conductivity is equal to kappa. How much did I get? 1 by 4 divided by 1000 into, what is the same concentration they've given to me here? They said I need to find for how much? And a molar conductivity of 0.5 molar solution. So if I have to substitute, I'll substitute for 0.5. How much do I solve? I get 1 by 2000, which is equal to 5 into 10 raised to the minus 4 Siemens whole units. That's it. This is the formula. So what is the answer? 5 into 10 raised to the minus 4, the first option. So the first option is an answer, correct answer. Let's come back and do the next variety of numerical that's based on your molarity. Fine, let's read the question. Fine. So what did they give us? If the density of methanol is 0.793 kilogram per liter, what is its volume needed for making 2.5 liters of its 0.25 molar solution? Okay. So basically, when such numerical is given to you, right? you should have a clarity of what data is given to you, where to substitute, what to calculate. So first of all, in this particular thing, let us write the given data. So in the first thing, given data is, when you write what is given to you, you'll have a clarity. So they've given us density of methanol. So density is equal to 0.793 kilogram per liter. That's over. So how can I convert this into gram per liter? So 0.793 into 10 raised power of 3 gram per liter. This is over. Fine. So next one, we have two things, isn't it? If the here, what is the volume to be needed? One volume is needed. They're asking for the different volume, right? So there are two things. First, we have one formula, isn't it? M1 V1 is equal to M2 V2. We're going to apply this whole information in that formula, right? So first of all, what are there when I have to write M1? Let us divide this into M1. This is V1 here. Let us write here M2 and V2. Fine. So what is M1 here given to us? Fine. So do we have M1? We need to find M1, because what is the volume needed to find for 0.25 molar solution? There are two things given here. Fine. So M1 and M2. Fine. So here M1 I need to find out. How much is M2? 0.25. Fine. 25 molar. Fine. Here in this case, volume also I need to find. Volume also not there. What is the volume here given? V2, they've given us 2.5 liters. So 2.5 liters, isn't it? Fine. This is over. Because we are going to divide it into solute and solvent, isn't it? Fine. This is how we are going to do. Now for calculating the molarity, first molarity is equal to you're going to write weight by, okay, this in directly also you can write, isn't it? Yes. Okay, let's see how can I write this. So your density is given, weight by molecular weight, but density is given. So how can I write this? I can write density is equal to density divided by mass. I can write this, isn't it? Yes, density is equal to mass by volume. But here, this is molarity, this is mass. Fine. How much is this coming up to? This is coming density 0.793 into 10 raised power of 3 gram per liter. Right, how much is the mass given? Right, so how much is this weight? I need to calculate the molar mass. What is that molar mass of methanol? Methanol is CH3OH. Now calculate for carbon. How much is that? For carbon, okay, 1, there's only 1 into 12 plus 3 into, okay, 1 into 12 methanol, this is okay, yes, 3 into 1.00 your 7 plus 16. When I do this, I get methanol weight is 32 grams. 32 gram per mole I've got. Okay, now substitute 32 gram per mole. Fine. So when you divide, you get molarity equal to 24.781 mole per liter. Okay, this is over. Now what did I get in this? Here I have got M1 I've got. Now substitute this M1 here in this case. Yes, so how much is M1? M1 is equal to 24.781. Okay, now you can do, isn't it? Yes, let us turn the page and do the sum. So what is M1 now? We have got two things, but let us write this formula 2. M1 V1 is equal to M2 V2. Now how much is M1? 24.781. V1 I need to find. M2 is 0.25. How much is V2? So take this V1 out. This goes the other way. 0.25 into 2.5 divided by 24.781. So V1 finally I've got an answer of 0.025 liters, because the volume is in liters. So this comes to 25.22 milliliters if I have to convert. Fine. This is how you are going to do the sum. See what data is given to you. See how to find out from the given mass or given information, and then finally take the final answer. This is how you're going to finally calculate, because they've asked us to calculate V1. Fine. Let us come back and do the next sum in this. So in the next sum, they've given us a sample of drinking water was found to be severely contaminated. Okay, right, with what? It was contaminated with chloroform essence. Fine. So and it's supposed to be carcinogenic in nature. The level of contamination was 15 ppm by mass. Express this in percent by mass, as well as determine the molarity of chloroform in water sample. Both the things they've asked me to do. Fine. So when such numerical is given to you, as I said, every time when such numerical is given to you, try to write the given data. When you write the given data, you'll have an idea, okay, what is given, what should I calculate. This is how you're going to do the sum, isn't it? Fine. So here express it in mass percentage as well as determine the molarity also. Both the things they've asked me. Fine. Let's start doing the numerical. First of all, what is given to us in a sample of drinking water, they said. Fine. So let's start noting the data. Right. So let us see the next question. Hope concepts are getting cleared gradually. See, you will not get the concept immediately. You need to keep practicing, then only you will understand. Fine. So next question. How many volumes of 10 molar HCl should be diluted with water to prepare 2 liters of 5 molar HCl? Fine. So here, in this question, what did they give us? Like how much volume? I need to find the volume, isn't it? Is how much volume they said. So simple. They've given 2 things. Let us note the data first. So according to this, the given data, the simplest numerical this is. Yes. So in dilution, like molarity, the dilution law. And what happens? What is the formula? M1V1 is equal to M2V2. So here, this is, let us take this as 10 molar HCl. Right, and the next one, okay, this is equal to, no, this quantity I'm going to take it as 5 molar HCl, right? So 10 molar, 10 into, I need to find V1 because how much volume they said, and this 5 into, what is the volume? 2 liters they've given, 2 liters. Fine. So V1 is equal to 5 into 2 divided by 10. Okay, this is liters. So how much do I get? I get 1.00 liters. This is how we would do it. This is the simplest numerical. Rather, there's nothing much. Given data, substitute in the dilution law or the molarity dilution law, and finally get the answer. Fine. So let's see one more numerical based on molarity. Here, this particular question, molarity and number of moles, both the mole concept as well as molarity are related. Let's see this question. So here, calculate the number of moles and the amount in grams of sodium hydroxide in 250 centimeter cube of 0.100 molar sodium hydroxide solution. Okay, fine. So here, what should I do when I need to solve this numerical? How can I do this numerical? Let's see. So first of all, number of moles, both the things, calculate the number of moles I said. Fine. So let us start from here. This is your main thing. 0.100 molar solution sodium hydroxide. How much is contained? 0.100 molar sodium hydroxide solution contains, what does it contain? It contains 0.1 moles of NaOH in how much? In 1 liter. In 1 liter, 1 liter. Okay, or I can write this as 1000 centimeter cube of a solution. Yes, I can write in this way. Okay, fine. So number of moles, if I have to find number of moles of sodium hydroxide, fine, in 250 centimeter cube of solution. 250 centimeter cube of solution. How can I write this? I write this as molarity into volume of the solution. This is liters. So how much is molarity given? It is 0.1. How much is the volume? 250. You're standardizing it to 1 liter, right? So molarity is equal to 0.1 into 250 divided by 1000. This comes to 0.025 moles of sodium hydroxide. Okay, this is over. Right. What should I find? I need to find the this one also, isn't it? The total. They've asked me to calculate the amount in grams also. There's also one more thing which I need to find. So when I have to calculate the amount in grams, so let's write. First of all, molar mass of sodium hydroxide. Molar mass of sodium hydroxide is equal to 40 gram per mole. Right. Fine. So now mass of NaOH in 250 centimeter cube, because that is what I need to find, is equal to N of KOH into M of KOH. This one formula. So N of KOH is how much? 0.025 into M of KOH is what? 40. When I multiply, I get 1 gram. That's it. So both the equations, hope these are clear, both the concepts. Let's come back and do the last variety of molarity numerical, which is there. Fine. So here, let us see the equation. 2.8 grams of KOH is dissolved in water to give 200 centimeter cube of the solution. Calculate the molarity of KOH in the solution. Okay, yes. So here, what should I find? I need to calculate my molarity. Direct formula this is. Basically, how let us write? Molarity is equal to moles of solute. Moles of solute by volume of solution in liters. Volume of solution in liters. Isn't it? Yes. Done. So here, what data is given? Moles of solute means nothing but weight by molecular weight, isn't it? But here they've given 2.8 grams of KOH is dissolved in water to give 200 centimeter cube of solution, they said. Right? So first of all, let us calculate the molar mass and then come back. Molar mass of KOH. Molar mass of KOH is equal to how much? 56. Okay, gram per mole. Hope this is clear. 1939, 60 plus 16 plus 1. So this comes to 56. So let us 56 gram per mole. So here 2.8 grams. This is 2.8 grams of water. Okay. 2.8 grams of KOH. 2.8 grams of KOH is equal to now. Like how much weight, isn't it? This should be the other way. Molar mass of this contains 2.8 grams contains how much? Okay. So what do I get? 2.8 divided by 56 moles of KOH. Okay. How much do I get? I get 0.05 moles of KOH. Okay. Now I've come almost closer to the sum. Now let's come back and write. So molarity is equal to now. Molarity is equal to, again I'm writing the formula, moles of solute divided by your volume of solution. Volume of solution in liters. Yes. So how much is the moles we got? 0.05. Volume of the solution 200 by 1000, which comes to 0.25 moles per liter. This is your sum. So this is how we are going to calculate the molarity of the gas. So I've done the various combinations, almost 12 numericals regarding molarity. Let's come back with the next set, that is calculating your or doing the numericals based on limiting reagent.
All right, welcome to one more session of your WOC. This is your Vani ma'am, back again with the important video. So what are we going to learn this time? So P block, you all know students, 10 marks is the weightage for term 1 examination. All right, yes. So what did I do? I have done or very carefully sat and I have prepared trends with complete P block 15, 16, 17 and 18. Take the trend, give the reason. Take the trend and give the reason. So please watch the video completely, note it with your hand, take a notebook and practice it. So these all will come in the MCQs. Let's see students. So when I go to group 15 trends, the important one is melting point. So I have written the order with the reason also why phosphine is having less. Reason also I've written. Why ammonia is having maximum, that also I have written. Reason is what? All right. And then slowly I took it to the boiling point. Same, I have written the trend and I have written the reason for both. Slowly then I took into the bond length. Bond length trend also is mentioned here, and along with that I have written the reason also. What is the reason why ammonia has 3 bond pairs and 1 lone pair? What is happening to the repulsions? Why is the size increasing? Why the bond length? Everything I have mentioned here in this particular slide. After this, I slowly took into a concept called bond energy. All right. Right, students. Bond energy, bond dissociation enthalpy. What happens? On what does that depend upon? What is the role of bond length? I have written the trend and I have written the reason also. Slowly from bond energy, I took you into a concept called bond angle. All right. So bond angle, when I see again the same concept, I have made the trend. I have written the reason for both. Why ammonia bond angle is more compared to your phosphine. Reasons are also mentioned so that you can use it for your MCQs. All right. After that, slowly I took into a concept called reducing power, that is the ability to release the hydrogen atom. I have written why ammonia is less and bismuth hydride is the strongest reducing agent. Both the cases, I have written the reasons, so please note it. All right. And important thing, then I have made two different tables, one for the basic nature and one for the stability. Everywhere I have written the reason. Please note it, students. So these are all the important trends of group 15. Next comes group 16. Important concept is acidic character. All right. In acidic character of oxides, what is important? Why this is more acidic character? What is the reason? Why the bond? Because of the bond length. How is it affecting? Everything I have mentioned here. Slowly I have come to a trend, that is thermal stability. Order also is mentioned here. Reason also is mentioned here. Yes. So please note it, students. Very important, thermal stability on what happens when I go down the group. Then slowly I took a concept called reducing character and reducing property of oxides. So what happens whether it's easy to lose the hydrogen atom? What is the reason? I have mentioned here. Same is with the oxides. So you should remember, based on the inert pair effect, how is it releasing the particular? So everything I have explained along with the reason, note it. Then comes boiling point trends based on hydrogen bonding. Then comes volatility factor, that also I have mentioned here. And slowly I took you into the next concept called bond angle. Why is the bond angle of water more than H2TE or H2S? Reasons I have mentioned on both the sides. Now slowly let's go into the trends of group 17. All right, all right. So group 17, melting and boiling point. Why fluorine melting point is less compared to iodine? Reasons are mentioned here, both the cases. Slowly, I took you into the next property, that is ionization potential, electronegativity, oxidizing power. What is the reason when all the trends are in the same thing? All right. Reasons are also mentioned here. Very important. Please note it. Everything is clearly explained line by line here. I took the trend of acidic strength. Observe carefully, students. Acidic strength. Order is mentioned. Reason is mentioned. Carefully, I have written. So, same thing you can remember for your MCQs. So, how is the proton released? Then comes one more with oxo acids, acidic strength. This also is mentioned. So this strength also is very important and how it depends upon the release of proton. Slowly, and then I took it to the reducing character, which is the most important part of your group 17. HI is the strongest reducing agent and HF is the strongest oxidizing agent. Noted. All right. Then I came to a concept called bond enthalpy. What is the reason why the bond enthalpy value for chlorine is more than iodine? Done. Bond length also I have taken here. Then I have taken into a concept called thermal stability. Again, which is more stable, which can easily release hydrogen atom. So these are all the trends of P block. Please note it. It took a lot of time for me to do this. Share the video with your friends. Thank you so much. WOC is always with you all. Thank you, students.
So we've already seen the definition of electron affinity in the previous video, students. So welcome back. Today we'll be almost completing the chapter, I think. Yes. So today let us see the factors affecting electron affinity. So it is also called as electron gain enthalpy, isn't it? Right. The first factor affecting the electron affinity, just remember these tricks, very important. Electron affinity is inversely related to atomic size. That Next important factor, which I've already explained in the tricks of inorganic series, electron affinity is directly proportional to Z effective, that is effective nuclear charge. If this is more, this also the value also will be more. Third important thing, electron affinity is inversely related to 1 by screening effect. I've already explained why is this inversely related, why is this directly related in the trick series. Last but not the least, the fourth one, electron affinity value is inversely related to 1 by stable electronic configuration. Now, so first of all, the these concepts, please go back to the inorganic series, that is your trick series, where I've explained the concept one after the other. As of now, just I gave you the concept here. Now, next important thing, I just mentioned it here, but explanation, please understand, go to the video, watch it, and then you will have an understanding about this. Here, for noble gases, the inert gases, the electron affinity inert gases is 0, isn't it? Why? Because of the configuration. That is, what is the configuration? NS2 NP6 configuration, isn't it? So there is no possibility of adding extra electron, right? That is first important. So let us write that noble gases, electron affinity value is 0. Done. Second thing, electron affinity value of if I have to say affinity value of magnesium, beryllium is practically 0. Why? Because extra stability of the completely filled shell. Okay, let us write that due to extra stability of completely filled s orbital, isn't it? S orbitals. Because if I take magnesium, 12, 1s2, 2s2, 2p6, 3s2. Completely filled, isn't it? That's the concept. Suppose if an atom has half-filled orbits, then electron affinity value will be very low. Right? So that also is one more concept where, what am I saying? Suppose if I take fifth group elements. So in fifth group elements, when I take fifth group, done. Here it is basically now you have the half-filled electrons, that is, suppose if I take 1s2, 2s2, 2p1. Fine, right. First of all, let's see. Let us take an example of the fifth group elements and then write. So now, normally, when I take a fifth group element in the periodic table, hope you would have seen the video of the periodic classification of elements, students. In that periodic classification of elements, your first group is your alkali metals. Second is your alkaline earth metals. Okay, third, fourth, like that. Suppose if I take the fifth group elements, boron, atomic number 5. So let us write boron 5. 1s2, 2s2. This only, the same thing I have already written. So the half-filled shell of this, half-filled orbits of this, the affinity will be very, very less because of the half-filled electrons. Now let's see one more important concept, variation of electron affinity value. Let me take out this page and let me see. Variation of value of electron affinity in a period and in a group. So let us write the heading, variation of electron affinity in a period. First we will see in a period, then we will go to a group. Right, fine. So when I speak about a period, electron affinity value, when I move from left to right, what is happening? The size is decreasing. When the size is decreasing, what will happen to the effective nuclear charge? Z effective, that increases. So in a period from left to right, what will happen? First concept, atomic size decreases. When atomic size decreases, what will happen to Z effective? Z effective increases, isn't it? Then that means the nuclear pull is increases. So what is the trend? Halogens will have more electron affinity value than oxygen family, then greater than carbon family greater than nitrogen family greater than metals of group 1 and 13 greater than metals of group 2 greater than 0 group. This is the concept. Yes, so this is the order basically based on the effective size and atomic size as well as Z effective. Done. Suppose if I take the trend, the electron affinity trend in the second period. So trend of electron affinity in second period. When I take the second period concept, so what are the elements? So basically beryllium will be less than nitrogen, less than lithium, less than boron, less than carbon, less than oxygen, less than fluorine. Suppose if I take, this is your second period. Now if I take the third period concept and see, let's see third period. Magnesium will be less than sodium, less than aluminium, less than phosphorus, less than silicon, less than sulfur, then chlorine. So according to the concept and according to the size, this is a trend in a period. Suppose if I have to write the trend in a group, right? What happens in a group? In a group, when I move from top to bottom, first size increases. When size increases, what will happen to Z effective? The pull of the nuclear charge decreases. What will happen to the electron affinity value? Electron affinity value also decreases. Done. So let's see the exceptional cases in case of electron value. Okay, effective exceptional cases. Because these questions only will be asked in the exam, exceptional cases. Remaining all normal trends, I don't think they will question you, but exceptional cases will be given in the CBSE exam as well as your competitive exam also. So in exceptional cases, electron affinity of fluorine is less than that of chlorine, of carbon less than the silicon, nitrogen is less than phosphorus, oxygen less than sulfur, right? So the such exception cases here you have to remember. So in case of second period also, because the size is less, very smaller size, isn't it? And the electron repulsion is more. The addition of this extra electron will become very difficult. So this is a basic information, students. So remember one important thing: the sequence of electron affinity. Suppose if I have to write 7th group, I'm writing it here only because the exceptions also. In the 7th group, order is iodine less than bromine, less than fluorine, less than chlorine. Right? Now, one important thing you should remember in electron affinity concept. Very important thing to remember. Remember this because they will ask you. Very important. What is that? Oxidizing power. Oxidizing power of element is directly related to electron affinity. Remember this, very, very important. Next thing you have to remember is reactivity of non-metals is directly related to electron affinity. Right. So these are the two important things which you should remember under electron affinity. So if you remember the trends, any question asked from any part is easy for you all. Thank you for watching, students. I'll meet you again in the next topic, that is electronegativity. Right, students, so welcome back to the inorganic series. So most of the students have been asking for this inorganic series. I felt like before I start with the concepts, you need to remember some important tricks for inorganic chemistry. Mostly reasoning questions are given in inorganic chemistry, and for that, to deal the reasoning questions, increasing order of acidity, decreasing order of basicity, how is the covalent nature, how is the magnetic moment, how is the bond order, oxidizing power, reducing power, all these questions. So here I'll be giving you 24 important tricks or important concepts which you should remember so that you can apply in any of the question given to you, right? So very important, as I did in organic series where I've combined the whole textbook into 3 pages. In the same way, I've combined all the tricks of inorganic chemistry in this concept, right? The first, I'll be giving you in sentence wise. Keep noting in your books and keep memorizing those. I think 24 is very less enough, isn't it? You can memorize and go and write in the exam, right? So the first important thing, I'll be going order wise. Keep noting in your books, please. First important thing you have to remember, if they give you a covalent character question, so remember, higher the charge in the particular element given, higher would be the covalent character. So remember this first important concept, covalent character. So if you remember this, it's easy for you to apply in the question. Next important thing you have to remember is bond length is inversely related to bond order. Remember this. Yes. Now, third important thing which I would wish to discuss is, this is very important for like gold number concept. So you can always say, if you have a gold number question, lower the gold number. I'm just giving you the tricks. Lower the gold number, higher is the protecting power, right? This is important. Next important concept which you should remember. Next, in physical chemistry, higher is these are all tricks which you can apply to different questions. I'm just giving you the trick how to remember. Higher is the critical temperature picked up one from physical chemistry. Greater is the ease of liquefaction. Remember this, right? Let us liquefaction. Let us go to the further rule. Next, important, right? So entropy, if I have to speak in terms of thermodynamics also, entropy, it decreases at surface during adsorption. Remember this. If they ask you a question related to entropy, this is the concept which you can apply to that. Next important concept, higher the number of unpaired electrons, in the given ion. I'm just giving you the clue. I'm mentioning again, given ion, highest will be the magnetic moment. Higher will be the magnetic moment. Remember this. Fine. Yes. Now let us go to some more trick. I said 24 I'll be giving you. Let us write one more. So next important. How many did I write? I've written 6, isn't it? Now let us go to the 7th one. If a question is given to you in oxidizing power, right? Remember, oxidizing power depends on positive reduction potential, okay, right? And it also depends on negative value of Gibbs free energy. These are all important things which you should remember before you solve. Next, if I have to speak in terms of general organic chemistry, minus I effect groups, they increase the acidity. Plus I effect group, they decrease the acidity. Remember this. Yes, done. The next important concept which you should remember, if they ask you about electronegativity equation or something like that, right? So electronegativity, like if I have to speak, okay, let me come back to the this electronegativity concept. As I said, yeah, electronegativity of central metal atom. Remember, all are different concepts here. Electronegativity of central metal atom, if it is high or if it is more, when you compare the order of reactivity, then bonded electron pair polarizes towards central metal atom, correct? So repulsion increases, hence bond angle increases. So the electronegativity of the central atom, if you find a series given to you, see the electronegativity of that particular one is high, then what will happen? Automatically it will try to drag the electrons towards it. When it drags the electron towards it, bonded electron also polarizes towards the central metal atom. So then what will happen? The repulsion increases. When repulsion increases, what will happen to the bond angle? Bond angle also increases. Done? Yes. Now, next concept. As the size increases, let us speak in terms of size and basicity now. First, as size increases, what will happen to the electron density? The electron density gets diffused over a larger surface area because the size is increased, right? So when the size increases, what will happen? The ability to donate electrons. Ability to donate electrons is nothing but basicity, isn't it? Right? So the ability to donate electrons, let us write that, donate electrons, okay, decreases. Why? Over a large surface area, hence that donating capacity also decreases. Remember this concept. Next, when I have to speak about oxides, right? Oxides, so that like whichever oxide you're speaking about, it decreases in a period, right? Decreases in a period. When I have to acidity, now when I speak about basicity here, basicity increases in a group. Remember this concept. I'll be applying this concept with other questions. Now, next one, 12th concept which you should remember. As I said, minus I effect. What does this mean? This is nothing but EWG groups, isn't it? Right. If you have EWG groups, they stabilize the anion. They stabilize the anion. When they stabilize the anion, what will happen to the acidic nature? Acidic nature increases. Remember this. If EWG groups are present, acidic nature increases. Then, now for isoelectronic species, suppose if they give you a question like isoelectronic species means having same number of electrons, right? So if they give you a question for isoelectronic species, what is the thing you should remember? If they ask you to find the ionic radii trend, right? Ionic radii, that is Rn, it is always inversely related to Z, right? Ionic radii, larger the atomic number, smaller is the ionic radii. Again, smaller is atomic number, larger is ionic radii. Remember this concept. Yes. Next thing which we will study. What is that? Lesser the number of, okay, I am relating with stability now. Let us speak in terms of stability. If they ask you which is more stable, then what should you do? You have to write lesser the number of antibonding electrons, higher is the stability. Higher is the stability. Remember this concept, very important concept. Done. Next, let us speak in terms of SRP now, on oxidizing agent. Okay, when they'll ask you which is a better oxidizing agent or something, you need to speak in terms of SRP. How is that? Higher the SRP, standard reduction potential, better is the oxidizing agent. Better is that this act as a better, if the SRP is higher, for that better is the oxidizing power or oxidizing agent, oxidizing power. Right, now let us go back to one more concept, 16th concept. What is that thing? Ligand field strength, right? So what is that? Ligand field strength is directly related to energy of light absorbed then it is inversely related to 1 by wavelength, that is lambda's wavelength of light absorbed. Remember this, of light absorbed. It will be useful for your first chapter. Yes. Now next important thing. More is a negative charge, delocalized due to resonance, more is a stability. So one more important concept. If the negative charge, more negative charge delocalized. When is this negative charge delocalized? Due to resonance. Due to resonance. Then what will happen to the stability? More is a stability. Remember this. Right. 18th concept. When they ask you in terms of isomers, which will show geometrical isomers or optical isomerism, like that. Remember, in terms of geometrical isomerism, double bonded compounds show geometrical isomerism. Remember this concept, geometrical isomerism. Right. 19th concept, which you should remember, hydration enthalpy. So they'll be giving you questions based on hydration enthalpy. So what will you remember in that? Smaller sized atom. If it is smaller sized atom, then this will have higher hydration enthalpy. Higher hydration enthalpy. Remember this concept, right? Higher hydration enthalpy. Now let us come back to 20th concept. What is that 20th concept? Is it? Now I'm going to speak again in terms of hydration enthalpy. What is that? Greater the charge. We are going to relate with charge. Greater the charge, smaller the size of the ion. Smaller the size of ion, greater the attraction of lone pair, then what will happen? Greater will be the hydration enthalpy. Greater is the hydration. These are all clues to remember. If you remember these clues, it is easy for you to solve any type of question given to you. Right. Next one. If I have to speak about ionization potential. So ionization potential increases with increase in number of electrons in the same atomic orbital. So remember this. What am I trying to tell you? Ionization potential increases with increase in number of electrons in the same atomic orbital. Same atomic orbital. Remember this. Right. Let us do the 22nd important thing. Yes. So 22nd. These are very important trends of your inorganic chemistry. When I have to speak about atomic radii, when I go from left to right in a periodic period, so this is your period. Now when I go down in a group, let us see. In a period, left to right decreases. In a group, it increases. Let us see ionization enthalpy. When I have to speak in a period, it increases. In a group, if I have to take, it decreases. Other way, isn't it? Now, let us come back to electron affinity. Electron affinity in a period, left to right, it increases. Down, it decreases. If it increases, it decreases. Next, electronegativity. Electronegativity here increases. Then when I go down this in a group, if this is increasing, this is decreasing. Metallic character, if I have to say from left to right, it decreases. And when I go from top to bottom, it increases. These are the complete trends of the periodic table. Yes. Now let us come back to the 23rd trick you should remember. Now E by R ratio we have, isn't it? So as E by R ratio increases, polarizing power increases. So remember this concept, very important concept. Again, I'm mentioning the important things once again. So let us do the last 24th one. Next, what should you remember? More lone pairs are present. So there are more lone pairs present, then bond angle will be smaller. Is smaller, right? And you should also remember LP repulsions are greater than LP BP repulsions are greater than BP. right? So these are all your 24 important concepts which will cover all acidity, basicity, oxidizing power, reducing power, atomic radii, everything rather. Please keep noting in your book and keep memorizing it, so that whichever question is given to you based on, because you will be given most of the questions based on the order, isn't it? Order increasing, find the increasing order, decreasing order, which is the right order, which is the electrode potential, how do you compare between this and all these, right? So then all these tricks will be useful for you. I'll come back and meet you again with inorganic series.